Alright, so with our applications, we're going to use the same direct, inverse, combined, joint variation that we did at the first part of 9.5, but now we're going to apply them to different story problems. We're going to test some of your geometry knowledge as well. Well, really, we're just going to see if you remember some of the things. So it says the perimeter P of a regular dodecagon varies directly as the side length S, and P equals 18 inches when S is 1.5 inches. Find S when P equals 75 inches. So really, one of the new things that we'll have with the applications is you are going to have to include units in your final answer. So we're just going to write a little reminder here that we're going to include our units for these. Do any of you remember what a dodecagon is?
12.
Yeah, 12 sides. A decagon is 10. The do makes it 2, so 12 sides. One thing that you want to focus on when you're reading this is the way that it varies. Okay, so it varies directly, and then we're going to identify what variables it is. So we have the perimeter P varies directly as the side length S. Once you have that, the first thing we're going to do is we're going to write our equation. Okay, so the first thing we're going to do is write the equation from that information. So we have the perimeter P, and then there's a variable that we always include in this. Do you guys remember what it is? K, great. Okay, so if it's directly, it's going to be multiplied, so it's K times S. So we're going to create the equation from that, and then we're always going to find K. Do you guys remember what K is called? Yep, the constant of variation. So we're going to find K. So sometimes in your homework, they're going to ask you to find the constant of variation. They're just telling you to find K. All right, so then what we're going to do is we're going to take what they give us. P is your 18, S is 1.5. Notice the units, right? So when we're finding S, we know that our units are going to be in inches. So if P is 18 and S is 1.5, we're going to plug those in and then solve for K. So to solve for K, I have to do what to both sides? Yep, great. You guys can use your calculator for this. I remember back when we had the no calculator SAT, I would make students do this without it. So crazy. If you did have to do it without it, do you guys know how you could do it really quickly? If it's 1.5, what could you multiply both those by? I would just multiply by 2, because what's 1.5 times 2? 3, right? What's 18 times 2? What's 18 times 2 though? 36. So 36 divided by 3 is 12. Okay, and then once you find K, then you have your variation equation. That is something else that sometimes you'll be asked to find. Okay, so if they ask you to find the variation equation, this is it. P equals 12S. If they just ask you to find S when P is 75, then you can solve in step 3 by using this equation. Now, notice that you do have to make sure that you are solving for the proper variable. So if you're finding S, you're going to have to divide both sides by 12. Okay, and if it doesn't say what to round to, try to leave it as an exact value if possible. Okay, so let's do 75 divided by 12. Okay, and you get a nice decimal? Yeah, 6.25. Okay, so our final answer is going to have the units. So the side length is 6.25 inches. You can write it out, or you can use the abbreviation. Either one is fine. All right, now for our next example, some more geometry here. It says the lateral surface area L of a cone varies jointly as the base radius r and the slant height L. Remember, that's the cursive L that they use for the slant height. Okay, and then they give you the lateral area is 63 pi. And the units are meters squared. So area is always going to have a unit that's squared. Okay, when r is 3.5 meters and the slant height is 18 meters. Find r to the nearest tenth when the lateral area is 8 pi meters squared. Okay, and the lateral, and the slant height is 5 meters. So just to give you a quick overview, do you guys remember how to draw a cone in 3 dimensions from your geometry days? Kind of draw like part of an oval, and then you make the top half of it dashed to show it's behind. Then you can just pick a point. It's really like you're making one of those birthday hats, right? The string on them. Connect each part there. Okay? And then the height goes from the top of the cone to the middle of the base. You can see the base is a circle, right? So when we're talking about circles, we always have the radius. The radius goes from the center to the edge. The height has a right angle with it, so this is your height here. And then the slant height is the height from the top to the edge. So when you would have done this, you would have used a certain formula a lot because this is a right triangle. And what's a really popular formula you use with a right triangle? Yep, do you guys remember what that's called? A squared plus b squared equals c squared? Yeah, Pythagorean theorem. Okay, so when you are solving this, again, the first thing I like to highlight is how it's varying. Okay, so if it varies jointly, we know there's going to be 2 multiples there. So it's the lateral surface area L of a cone varies jointly as the base radius r and the slant height L. Okay, so then when you're doing step 1, which is I just want you to write the equation. So L equals, you always have your K, and that's getting multiplied by r, and it's getting multiplied by the slant height, which you use your cursive L for that. And then your second step is going to be to find K. Again, this is called the constant of variation, and that is sometimes what you'll be asked to find specifically in your practice problems. That's what it means. You find K. Alright, so then it says L is 63 pi, and then you don't have to use the units when you're solving. That's just to help you with your units of measurement, making sure they're the same. And then your K is what you're solving for. It says your R is 3.5 meters. So we'll plug in 3.5 for R. Slant height is 18. Okay, and then we're going to solve. So the first thing we're going to do is multiply those together. 18 times 3.5, which is what? So you should get 63 when you multiply. So when you're solving for K and you're dividing both sides by 63, you will get an exact answer. We're not going to round it. We're going to keep it exact. So your value of K is what? Pi. So when you plug that in, your lateral area is pi RL. I don't know if you remember this far back, but that's the actual equation, is pi RL. We're finding the lateral area. Okay, and then our next step is going to be to find r to the nearest tenth. So it does say to the nearest tenth, so we will make sure we round appropriately. Okay, and they give you L is 8 pi, so I'm going to plug that in to this equation. So 8 pi equals pi. Your R value is what you're trying to find, so I'm just going to put times R, and then your slant height is 5. So when you're dividing and you bring multiplied by 2 factors, you can just divide by 5 pi. The pi's will cancel, the 5's will cancel, you'll be left with R. And then on this side, pi divides by pi, so it's 8/5. Now, because they tell us to round, we are going to round, but sometimes you might just use that 8/5 exactly. And when you divide, you do get an exact decimal. So we're going to use the 1.6 as R, and then of course we're going to include the units. So we had the meters and the meters squared. The meters squared is only for area. If you look here, the R is measured in meters, so this is going to be meters as well. And so that's your final answer. Okay? So for any story problem, you're going to include your units. If they give units, then you're going to include units. Okay, for example 8, I'm going to give you just a minute to read over it, and then I want you to do step 1, where you just write out the equation, okay? So I'm going to give you a minute to read through it. Feel free to highlight or underline as necessary. Okay, and then Senna, can you tell me what you wrote out for your equation? Just with the variables. Great. Okay, so for this one, it varied inversely. So if it varies inversely, whatever they give you first is what you're going to write first. So the time varies inversely as the runner's average speed, s. Okay, so s goes in the denominator. Okay, so now it says a runner with an average speed of 8.82 miles an hour completes the race in 2.97 hours. Write the variation equation for the time t it takes a runner to complete the race with an average speed of s. So the variation equation is going to be finding k and then plugging it back in. So to find k, you're going to plug in the 8.82 for your speed. And then if it gives this to you in hours, you know it's your time. The 2.97 hours is your time. Whenever you're solving with a fraction, you always want to multiply by what? The denominator. So we're always multiplying by the denominator. Now, this didn't tell you specifically what to round to, but if you look at these values, they're rounded to the nearest hundredth. So let's keep that part the same. So if you're rounding 8.82 times 2.97, okay, whenever you are rounding, you are going to look at the value after that place. So I'm just going to put dot, 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 because it does keep going. So the 19 is followed by a 5. That's going to push that up to 26.20. And if you're rounding to the nearest hundredth, you have to keep the 0 on there. If it said to round to the nearest tenth, then you could just put the 0.2. So it really does just depend on what the directions are asking you for. Now your variation equation is t equals 26.20 divided by S. So it asks you for the variation equation. This is the variation equation. In the variation equation, you have K plugged in. The other two are not. Okay, and then the next step, it says, what is the average speed? So you're trying to find S of a runner who completes the race in 3.5 hours. Okay, so you're going to be solving. Okay, so you're going to find S when T equals 3.5. Okay, so go ahead, plug that in and solve if you can, and then we'll check in and make sure you're doing it correctly.